I got it. All right.
Hello, everyone. Welcome to the September JSE webinar. I'm Lee Harrell Williams. I'm an associate editor for JSE, filling in for Michelle Everson, who's teaching right now. In a moment, I'll introduce today's speaker. I just want to take a moment to remind everyone how the webinar will work. Our speaker will be talking for about 20 minutes. Then we'll have time for some questions and answers. If you have any questions, please type them in the question box anytime during the presentation or afterwards. I'll ask the speaker those questions, and then we'll open it up to a question and answer session where I can unmute people who raise their hands. I'm very excited today to present Jennifer Kaplan from the University of Georgia. She's going to be talking about a paper that she co-authored in the July 2014 issue of JSE about understanding students' understanding of histograms. And Jennifer?
Can they hear me?
Yes.
Excellent. So first of all, I want to thank Michelle Everson, the journal editor, for inviting me to give this talk, and Lee for stepping in to host while Michelle is teaching. And thanks to everybody who's on the webinar. I think a couple of my co-authors, John and Phyllis, may be on the call heckling me. Good thing they're muted. And then I want to say Chris Malone at Winona State was also part of this research group. So I'm going to say enough that if you haven't read the paper, it will make sense, but I'm going to leave out a few of the details that are in the paper so that I can give you the highlights of our work. And as Lee said, I'll talk for about 20 minutes and then open it for questions. But Lee, if anybody has clarifying questions in the middle, you can feel free to interrupt me.
Okay.
To let me know. So I want to start just by giving you a little bit of a thought question. So here's a histogram. It's a random sample of 356 adults living in Atlanta, a histogram of the yearly incomes of those adults. And my thought question is, what is the purpose of histograms? Why do we use them? And what would make a good complete description of this display of yearly incomes? And I'm going to come back to that later. This is something that's an extension from the paper. It's not exactly in the paper. So I want you to think about that while I'm talking. So we identified in the literature 4 common misconceptions about histograms. So the first one, not understanding the difference between a bar chart and a histogram. A lot of you may have heard students say, well, the difference between a bar chart and a histogram is that histograms don't have gaps between the bars and bar charts have gaps between the bars. And they're clearly not understanding the difference between the type of variable that's represented, a bar chart representing a categorical variable and a histogram representing a quantitative variable. The second misconception is confusing what information is contained on the x-axis or the frequency axis, the vertical axis, with the data values that are on the y-axis, on the horizontal axis, and not being sure what the meaning of those axes and what the information is contained there. The third misconception, it's sort of an offshoot of the second one. If you don't understand the information contained in the 2 axes, you might be confused about where to look to assess the degree of variability in a data set that's been displayed as a histogram. And so you might think that a flatter histogram, if you think that the horizontal axis contains the data values, you might think that a flatter histogram shows less variability than a bumpier histogram. And then the fourth misconception that we identified is viewing a histogram as a time plot even when there's no time, thinking that the horizontal axis is always about time, so the left side of the axis is earlier in time and the right side of the axis is later in time. So we discovered these misconceptions, we went through the literature, and then we created or found some items that we thought would assess whether students truly do have these misconceptions, whether they have them at the beginning coming into a class, and whether through instruction we address these misconceptions. So we created an instrument, and a lot of the instrument is available in the paper. Some of the problems are from the chaos test, and the chaos authors asked that we not publish those items directly, so those are described in the paper. I'm going to talk about a subset of the items in the paper, at least one for each of the 4 misconceptions, and let you know what we found in our data in terms of these misconceptions. So in terms of misconception 1, students not understanding the distinction between a bar chart and a histogram and why the distinction is important. One of the questions we asked, we gave them this bar chart of birthplaces of people in Michigan, and we asked, can the median of the data be found? And my convention in these slides is blue indicates the correct answer, red indicates the incorrect answer, and if I've used any other colors, that's to remind me that I want to say something about the other, they're usually incorrect responses, but something I want to say, I have something I want to say about those responses. So in this case, we see that just under 40% of the students came into the class saying, no, we cannot find the median, even if we had more information. And that went up to nearly 50% by the end of the class. And I should say these data were collected from one institution. They represent, the pretest was over 300 students. The matching post-tests were about, I think, 240, 250 students. So that's the sample size. It's across a number of different instructors and across more than one semester. And again, those details are in the paper. So we were not particularly impressed with the growth over time, that still only 50% of the students understood that for a categorical variable, one cannot find the median. You know, there are no medians in categorical data. We have a second question that we asked to try to get at the difference between bar charts and histograms. And basically, these are graphical displays of the number of medals won by a number of countries in an Olympic Games. And A, B, and D are all bar charts, one Pareto, one in alphabetical order. B is we create that order so that the middle bar has the most medals, and we make it look a little bit bell-shaped, unimodal and symmetric by just every other bar. And then C is the only one that is, in fact, a histogram. And the question is designed, the students are supposed to, the correct answer is the one that is the histogram, which is option C. And here we see that only 10% of the students at the beginning of the semester are drawn to that histogram. And at the end, only 16% are drawn to the histogram. And the reason that option B, the bell-shaped histogram, is highlighted in purple is because I wanted to note that while the wrong answers are somewhat equally likely at the beginning of the semester, or at least the Pareto and the bell shape are sort of equally likely among the students, at the end of the semester, 60% of the students are drawn to that unimodal symmetric looking graph, that graph B, and that speaks to us, and I'll talk about that. I'll talk about it a little bit later, but I just wanted to make sure I noted that as I went through this slide. So that's misconception 1. For misconception 2, we had 2 questions. So misconception 2 is not knowing what information is carried on each of the axes. So in the first histogram, we basically asked them to identify the median SAT score. And in the second, we asked them to identify the group that had the larger mode. And in terms of the median SAT score, we gave the 575 was one of the options, but 40 or 41, which is the height of the middle bars, we gave those as an option, and 19, which I believe is the median of the bar heights, was also a possible score. With the second question, the options were girls, boys, or they are the same. You have to look at that x-axis to see that although the 4th bar is the modal bar in both those categories, because the marking of the x-axis, the horizontal axis, is different, the mode for girls is more like $40 and the mode for boys is more like $25. So we found about 75% of the students got the median SAT score correct, but when we looked back at this question, we realized that if you know that SAT scores run from 300 to 800, 200 to 900, then the other options, the 40, the 41, the 19, the heights of the bars don't make sense. So we don't know whether students got this right because there were only options, the only options that were on the right scale for SAT scores were also the right answer, or whether they really are attending to the correct axis. And so we're thinking in the future we may need to either change the bar heights to have a much larger sample size, or to change this to an ACT question, because ACT scores are on a lower range. And in terms of the which group has the larger mode, we realized that because the bars are the same height and the fourth bar in, when for students who said the modes are roughly the same, we don't know which direction whether they're attending to the height of the bar or whether they're attending to fourth bar from the right. So we need to do a little bit more work with these questions before we can make any judgments on this misconception and whether it does exist. For misconception 3, believing that flatter histograms exhibit less variability, we showed them pictures of 5 histograms and asked which data set has the least variability. The response is there. So the correct one for the least variability is class A, the one with the large center peak and the short tails. And at the beginning, we had, note in the purple, we had nearly 60% of the students were looking at the tops of the bars. They picked that flat histogram. The students who chose the correct answer went up to 26% by the end of the semester, which is a little bit better than guessing, because with guessing we would only expect 20%. But we're still getting 50% of the students talking about that bumpy, that flat graph, the uniform graph. And in fact, this is a theme that's going to come up again later, the number of students who picked that bell-shaped graph on the end, that has also gone up. So we have 2 that are unimodal and symmetric, and both of the response patterns for both of those have risen. But not as much to the correct one as we would like, and we still are seeing evidence of that. Flatter is less variability. So now moving on to misconception 4, are students seeing a time element? So we showed them this histogram and asked, are there 3 times during the semester in which the students spend a lot of money? If you see it as a time plot, you should say yes, that's what I see. In fact, only about 1/3 of the students seem to see that, but it didn't change over the instructional period. So the students who, the number of students who came in thinking that way, that persisted across time. And in the paper, I think we talk a little bit more about the matching, matching up some responses. I don't have that information here. One of the issues with this is we don't know whether there are people who said false because one of the bars is higher than the other 2, and maybe they're saying no, it's higher at the beginning but not at the other 2. So we think there's a little bit of evidence that this might be that this misconception may be out there, the misconception of the time element. But we're not. We think we need to do some more work to really sort this one out. So to sum up, in terms of the 4 common misconceptions, misconceptions 1 and 3, 1 being the confusions between bar charts and histograms, we believe we do have evidence in our data to suggest that is a problem for students. Misconception 3, thinking that flatter histograms equate to less variability. We believe we have evidence that misconception really is out there. Misconceptions 2 and 4, we feel like we need to do a little bit, we need to do some more work to sort out whether that is really occurring and to what extent it's occurring, and before we're ready to move forward with those two misconceptions. So now I asked you at the beginning 2 thought questions. What is the purpose of a histogram, and what makes a good complete description of the display? So the reason that I wanted you to think about what is the purpose of histograms is because a number of people, after I've talked about this work or after the paper came out, have said to me, well, should we just, if histograms are so difficult for students, if they're really not making sense of them, should we just ditch them? Should we get rid of them and find some other way to visualize quantitative variables? And my answer to that is no, unless somebody can tell me how we get through sampling distributions without histograms. And that's not really me talking. There's a citation in the paper. Robin Locke and George Cobb have both talked about the fact that in order to understand inference, whether we're thinking about a randomization-based inference or the classic central limit theorem, one has to understand the distribution, the theoretical or the randomized distribution of the sampling, of the sample distribution of the statistic that we're considering. And I have not yet figured out, and nobody has suggested to me yet, but I will take, if somebody wants to say something during Q&A, how we can help students understand the sampling distributions without histograms. Until we can do that, I think we can't just say, no, we have to get rid of histograms. I think pedagogically we're going to need those, and for understanding we're going to need those. Now, as to what makes a good complete description of the display, I do a lot of work with the AP statistics programs, and I know from the attendee list there are a number of high school folks in the audience who I assume are probably part of the AP statistics community, or if they're not, maybe they should be. But in AP statistics, we're looking for shape, center, variability, and context. And that's the way we tend to grade descriptions. We're looking for those 4 categories, shape, center, variability, and context, when students are providing descriptions. So we actually, as part of our data collection, we had students describe histograms in paragraph form. And I have 2 separate results from 2 different data collections, one from the original data collection and one from a new set of data collection we did this past spring. So how do students describe histograms before instruction and after instruction? And then how do students describe histograms after instructions if we give them 3 different prompts? So in the first one, pre versus post instruction, in this one they were shown a unimodal roughly symmetric histogram of the number of hours that a sample of college students had slept the night before. And pre-instruction, we got things like students tend to get 6 to 8 hours of sleep at night. So for those we coded as they told us the center and they told us the context. We have a little bit of the story that and where the center is. Post-instruction, we saw a lot of the graph is unimodal and symmetric with median 7. So now we're getting shape and center, but the story is completely gone. They're not telling us anymore that this was about hours of sleep, that this was about college students. I mean, this is the worst case of really no context, but there was a lot less story post-instruction. The students knew to say shape and center. They forgot that there should be a story. And the sort of the subtext here is also notice that there's not a lot of talk about variability, and there wasn't much talk of variability either pre or post instruction. So that's an area for improvement. Now, in terms of the student description of histograms, this was they had the graph that I showed you, the unimodal with right skew graph of incomes. And we randomly assigned, that we have about 1,200 responses to this. Students were randomly assigned one of the 3 prompts, describe the distribution, being sure to tell us about context, describe the graph, tell us about context, or describe the distribution. And we didn't promote, we didn't put anything, we didn't let the clue the students to context. And so the differences in these responses, that middle one where we didn't say anything about distribution, we just talked about graph and context, those were more likely than the other two to have context. And when we asked them to describe the distribution and we didn't cue context at all, a lot of those students simply said the graph is right skewed. They only gave us shape and they didn't give us anything else. And so this is we're starting to think that this word distribution comes to mean shape for a lot of students, that when we say distribution of a variable, we think distributions have shape, center, and variability. Students, when they hear distribution, that cues the word shape for them. And so that's what we're sort of starting to think about that. So I'm getting, ooh, good. This is my second to last slide, and I'm getting to my 20 minutes. So future directions. So one of our future directions is going back to the student description of histograms. This semester, we're collecting more data on a more unimodal and symmetric graph, giving the same types of prompts for a different situation. We want to see if these results hold for different shapes. So that's one of the things that we're currently collecting data on. In addition, we collected data last spring that we haven't had time to analyze, where we gave students pairwise graphs, tell us which of the two histograms, which data set shown in the two histograms has more or less variability, and then we ask them to explain their choice. So we have some paragraph answers, and we haven't had time to look at those so carefully, but one of the issues that's come up is maybe if we gave students dot plots instead of histograms so they could see the individual points, maybe that would help them to sort out what they're looking at and make better judgments about variability. So this fall, we've changed every histogram from the pairwise comparisons into dot plots, and we're collecting, using the same prompts, the information about the dot plots. We also have collected student writing about why they chose, going back to which group has the higher mode, asking the students why they made their choice, and going back to the number of medals won, and where they're choosing between bar charts and histograms. We've also collected paragraph answers where the students tell us why they made their choice. So we have a lot of data analysis, qualitative data analysis of this writing to be done. If anybody wants to help, that would be great. But that's where we are right now. We are not ready to make suggestions for what we need to do in the classroom. We're still sort of working through the basic research of trying to figure out what mistakes students are making and why. Although that issue of the unimodal and symmetric, trying to figure out why students what it is about the way we're teaching that draws them to those Gaussian, those unimodal symmetric bell shapes at the end of the semester. And the other issue I think that has started to percolate is we teach the difference between we tend to teach the difference between categorical and quantitative variables at the very beginning of the semester, but it looks like at the end of the semester students still aren't quite sure why that's important, and maybe we need to think about how to thread that idea, the idea of the choice of your analysis, the choice of your graphical display, the choice of what measures you're reporting really does hinge on the type of variable you're looking at, whether it's categorical and quantitative, and that may be something that would help with the not understanding the difference between a histogram and a bar chart. So I think I'll stop there. I may have gone a little bit over my 20 minutes, but and take questions, but I do want to thank you for your attention, and there's the link to the paper.
Thank you, Jennifer. We do have a few comments and questions. I'm going to ask the questions first. The first one says, I haven't read the paper, so this might have been addressed in the paper, but she wonders about a misconception number 5, which is a hybrid between number 2 and 4. So a misconception about how many variables a histogram displays the distribution of. Did you have anything that addressed that question?
That is an excellent future direction. It is not addressed in the literature. I don't know that anybody has. My recollection of what I read to do the lit review, that's not something that has been addressed, but it's something that we could pretty easily collect data on. So I'm going to put that on my list.
Okay, another question is, how does the distribution of your students' math aptitudes compared with aptitudes nationwide or worldwide?
Oh, so the data that are represented by the paper, so it's hard because I can't show my screen and look at the paper. We do have information about what high school classes they took, whether they've had statistics before, how many math classes they've taken. This was a sample of students. I think I can say that they were at Grand Valley. We have no reason to believe they are not typical students. The new data collection, I'm doing it at the University of Georgia. So they're typical University of Georgia undergrads who take our intro stat class. And again, I have no reason to believe they are particularly different. They're not, they're students at large universities, not students at elite universities. But I have no reason to believe they're any different from your typical intro stat student.
So I have a comment here from one of your co-authors that Chris Malone had a thought on that comment about misconception number 5, that maybe using a 2D graph to show a 1D data might be the tripping point. So something to think about. And then another question, how do you address the variability in uniform histograms for student understanding?
How do we address it?
Yes, how do you address variability in uniform histograms in the class when you're discussing histograms?
So as I said, I don't think we are at the point of, and if one of my co-authors wants to type something in or be unmuted, I'm not at the point where I'm comfortable making suggestions for instruction. I know that at least one of my co-authors did address the flatter histograms have less variability issue in his class in a way that actually caused all the students to answer differently from the other students in the sample, and that is in the paper. I think we don't suggest doing that because that was the bit they remembered. I personally have a somewhat long activity that I've done with pre-service teachers where I talk about number of goals scored by soccer teams and what would make a league look more fair or less fair. And I have the students go from making case value graphs that show 1 bar for each team to making a histogram of the number of goals scored by the teams to try to help them see the transition between a case value bar graph and a histogram, and thinking and using the idea of fairness and what would be the most fair league and the least fair league in terms of parity. So those are the things I've done to try to help students see where the variability is coming in. But as I said, we're really not at the point of making too many suggestions for instruction yet. We're still working more on the basic research of what's going on with these students.
Okay, and then one last question. We are running a little late for those of you who do have to head out. This will be recorded, so you're welcome to come back and watch the later on. But we do have one person with their hand up, so I'm going to unmute David so he can ask his question. Okay,
Hi
David
there.
Doan, go ahead.
Yeah, hi. It's not a question really. I think some of the difficulty arises from Excel and its ubiquity. Excel creates gappy bar charts and calls them histograms, even if you are trying to create a histogram. I think that's part of the problem. Excel does not offer an option for a numerical X scale. It thinks that everything is a categorical variable. So that creates some difficulty for students. I don't know if that's been your experience, but everyone seems to use Excel and they want to use it to make histograms unless they're using Jump or some other software. Any comments on that?
My comment is that I don't think any of the courses from which the students came, the students in our that we've been using as our subjects, none of those courses use Excel as a statistical package. I can't remember what Grand Valley uses, but at UGA we use StatCrunch. So if they may have used Excel previously, but that would have had to have been in high school. So I'm not. So while I do feel your pain, because I feel the same way you do about Excel, I'm not sure. I mean, we would need to, and I'm writing myself a note. We need to, in order to make that connection, we'd need to collect some data on whether students are actually using Excel or have in the past.
Great. Well, we're at 35 minutes here, so I think we're going to wrap up. And I want to make a few announcements. Thank Jennifer first and her co-authors for sharing their article with us today, and those who submitted questions. A few announcements about webinars in the future. We're going to have an October JSE webinar. The time and date are going to be announced soon, so watch out for that announcement. There is a teaching and learning webinar on September 23rd at 1 p.m. about the Statistics Education Wikipedia page. Note that that's a different start time than the normal 12 o'clock start time. And lastly, when the webinar ends, you'll be able to give some feedback about your experience. We do like to have information about that, so please take a moment and answer those questions. Thank you, and have a good day.